Having a robust monitoring stack on Kubernetes is essential to ensure the reliability, performance, and security of your applications and infrastructure. With real time dashboards and correlated insights, the team can optimize resource usage, enforce SLOs, and minimize downtime for modern cloud native environments. Hello, everyone. Welcome back to the channel. Today, we will learn how to deploy a production ready monitoring stack on Kubernetes, including Prometheus for metrics, Loki for logs, and Grafana for visualization. Let us take a look at the architecture overview and the different components and their functionalities. First, Prometheus server, which periodically scrapes and stores metrics from Kubernetes and application exporters for monitoring and analysis. Prometheus uses Kubernetes service discovery to systematically find and gather metrics from different services within the cluster, like DNS and other sources. Loki collects, stores, and indexes logs sent by Promptel agents, making them searchable and correlatable with metrics in Grafana. Promptel agents run on each node to collect logs and metadata, forwarding structured log streams to Loki for centralized storage. Grafana visualizes both metrics from Prometheus and logs from Loki, letting users create interactive dashboard and alerts. Together, these components deliver unified monitoring and logging for Kubernetes workloads, enabling real-time observability, powerful querying, and rapid troubleshooting. It's time to install the monitoring stack. As a prerequisite, make sure you have a Kubernetes cluster ready, kubectl configured, and you have Helm installed on your machine. I will use the kube-prometheus-stack Helm chart from the Prometheus community repo, which deploys Prometheus along with exporters and Grafana, fully configured and production hardened. This chart includes service monitors and pod monitors for Kubernetes native scraping. Let us go ahead and create a namespace called monitoring to install our Prometheus chart. I will run kubectl create namespace monitoring command. Once done, let's go ahead and add the repository by running helm repo add command. Let us run helm repo update. In order to check the chart version, we can run helm search repo, then Prometheus community. In our case, we are going to install the kube-prometheus stack, and the chart version is 79.8.2. You can run helm show values command to take a look at the default values. These are the default values which you can customize based on your requirements. I have created a custom values.yaml file based on my requirement. It is in my GitHub repo. The link will be in the description below. I have already cloned this repo to my local, and I have opened it in the VS Code. Let me walk you through what all changes I made to make it production ready. First, for Grafana, we're going to enable the persistence, and the flag is set to true. This ensures that the dashboards and other settings for the Grafanas are retained across the pod restart. I have a storage class called Longhorn. I'm using Longhorn for my persistent storage in my cluster. Also, I have set the kubernetes.io/pvc protection. This would ensure the PVC from accidental deletion and also ensures PVC is not deleted upon Helm uninstall. We don't want to run our pods as high privileged ones. Hence, I am ensuring Grafana runs with appropriate user permission to access mounted volumes. I also defined the initial delay and timeout values to give Grafana enough time to initialize. I'm running a single replica. You can scale this based on your needs for redundancy. I'm going to retain the data for 30 days. You can change it. Let us go ahead and install the kube-prometheus-stack on our cluster. Let me navigate to my repository. And I have the Prometheus-stack values.yaml file. Let me go ahead and run the helm install command to install it in our cluster. I'm running helm install and I'm calling my release as Prometheus and will be deployed in the namespace monitoring with our custom values.yaml file. Let me hit enter. Let us check the status of the deployment by running kubectl get pods command in the namespace monitoring. Let us keep a watch by running -w. All our pods are in up and running state. Let us go ahead and check the service in the monitoring namespace by running kubectl get svc-n monitoring. We can access the Grafana dashboard using port forward since we are using cluster IP service. I would run kubectl port forward service Prometheus Grafana in the namespace monitoring, and we're going to use a local port, a 3000 mapped to port 80. You can access the dashboard by navigating into your loopback address with port 3000. Let's go to our browser, open a new tab, and search. This is the Grafana, the welcome page. We can log in using our default username and password, which is admin. This would prompt you to enter a new password. Let's quickly go ahead and set up a new password and submit. And this is the Grafana dashboard. We can click on dashboards. It comes with default dashboards. For example, let me click on the compute resources cluster. This gives you CPU utilization, the memory utilization, and other metrics. If I click on explore, we currently have only Prometheus installed. We don't have Loki. Let us use the Grafana Loki stack Helm chart from Grafana repo to deploy Loki Promtail and integrate Loki as a data source in Grafana for centralized logging. Let me go ahead and add the repository. Let me cancel this. We'll run helm repo add Grafana, then run helm repo update. I have created a custom Loki values.yaml file to install Loki on our Kubernetes cluster. I have a file called Loki values.yaml, which is set to true. This activates the Loki component in the setup for log aggregation. The replicas is 2. This is an optional limit, which you can set for read-write replicas. The config section defines the storage schema. The store is set to TSDB, the time series database, a recommended index type for storing logs using Loki. Object store is set to file system in my case because I'm using a local setup with Longhorn. In case you have an S3 or GCS, please go ahead and update this object store accordingly. The rotation period of 24 hours to create a new index every day, which helps with query performance. The replication factor is set to 2. This limit writes to 2 replicas. If we scroll down, we have prompt tail, which is enable is equal to true. This activates prompt tail for log collection. I'm setting the endpoint for prompt tail to push logs to Loki. This is the Loki service URL within the Kubernetes cluster. You can set the file name where prompt tail store the position for each log it reads, ensuring logs are picked up from where it left off. You can also adjust the Kubernetes service discovery. For example, you can go ahead and define it here. You can update the labels, etc. And we also enable RBAC to ensure prompt tail has the necessary permission to read logs. Let's head back and install Loki on our cluster by running helm install command. I will run helm upgrade install Loki, then the version 2.10.2. Then we're going to use Loki values.yaml file. Let me hit enter. Let us check the deployment status by running kubectl get pods -n monitoring, and we'll keep a watch. This is deploying the Loki on our cluster. Let me exit and check the status again. We have all our Loki components up and running. Let us access our Grafana dashboard by using port forward. Let's head back to our browser and refresh. Let us click on connections on the left-hand side. If I expand this and click on data sources, we should be able to see Loki in the data sources. You can just scroll down, click on save and test, and you should have a successful connection. If I go back to explore, I can choose Loki. We had only Prometheus. We can see Loki now, and we can basically check the logs. For example, I can choose namespace equals, then I would select Longhorn system and I would just run the query. And we can see we have some errors. We can filter and start troubleshooting if we find any issues. Let me show you how to create custom dashboards so that we can get most out of our Grafana. If you click on dashboards on the left-hand side, then click on new, we can add new dashboard, new folder, or import existing dashboards. Let me click on new dashboard. So the import dashboard option will give you to import an existing dashboard from a file, or we can go to grafana.com, which I'm going to show you. Let's click on grafana.com. We have a lot of options here. For example, let us take node exporter full. We can copy the ID, or we can download the JSON. Let's head back to our Grafana and I will click on import dashboard and I will add the ID, then click on load. This would go ahead and import the dashboard. You can name it. I will just let it node exporter full and click on import. So as you can see, this basically imported a beautiful dashboard, which would allow you to check the CPU usage, the memory usage, etc. We can basically check for log, maybe for last 1 hour, how our nodes are performing. This is for the master node. I have 3 worker nodes. We can check for the worker. We can scroll down and it will give you more information like the CPU metrics, the memory metrics, etc. This is really helpful if you have some issues for the infrastructure. We can go back, also create one for Loki. Let's create new dashboard. You can go to the grafana.com. Let's go back again and search for Loki. And I'm going to add the Loki Kubernetes logs dashboard. Let me copy the ID to the clipboard. Let me head back and import dashboard. Let's click on load and select the data source, in this case Loki, and I will call it Loki Kubernetes logs and click on import. So this will give you an option to filter logs, for example, by namespace. Currently it is showing for all. We can select, for example, I want to see the logs in the kube system namespace. Then I want to see the logs for all. I can just select specific pod, for example, maybe for core DNS, and it will show you the logs related to core DNS. So this is very powerful, which would allow you to quickly identify the issue and debug. Congratulations, we have successfully deployed a production-ready monitoring stack on Kubernetes, including Prometheus for metrics, Loki for logs, and Grafana for visualization. If you found this video helpful, please like, subscribe, and follow for more Kubernetes-related videos. Thanks for watching.